Greetings. In the previous video, we discussed the big picture of what artificial intelligence is in general terms. But today, we're going behind the curtain, into the real kitchen of this gigantic brain. If you think of artificial intelligence as a state-of-the-art Formula One car, data is the fuel for that car. You can have the world's best engineers, the most powerful engine, but if you put dirty, low-quality fuel in the tank, that car won't even leave the track. Today, leaving aside complex academic terms, we'll talk about how to read data, what the name of the problem we're facing is, and why that famous garbage in, garbage out principle is the sacred rule of the digital world. If you're ready, we'll start with the alphabet of artificial intelligence, that is, the soul of data. In the world of machine learning, everything starts with a massive table, but to read this table like an AI specialist, you must understand two critical concepts, features and labels. Let's imagine you are a real estate agent. You have the square footage of a house, the floor it's on, the number of rooms, and its location. These are our features, our clues, our inputs. So, what are we trying to find at the end of the day? The sale price of the house. That price is our label, our target outcome. Let's add another example. Imagine you work in a bank's credit department, a customer's monthly income, age, past debt repayment, performance, and years at their current job are all features. The answer to the question, should this customer be granted a loan or not, is the label. AI acts like a highly skilled detective. It finds the hidden mathematical patterns between the features' clues, and builds a reliable bridge to the label. The result, once you provide it with thousands of past examples, it gains the experience to analyze a customer or a house it has never seen before. We've gathered our data and separated the clues from the results. Now, which box do we put this data into? Here, the road forks in Tiffif. What you want to predict is a continuous number. We call this regression. Questions like, exactly what will the temperature be tomorrow? What will the price of this stock be tomorrow? Or how many centimeters will this sapling grow in a month? Are open-ended. The answer could be 10, 10, 5, or even 1000 if you are looking for a specific point within an infinite range of numbers. Your problem is a regression problem, however. If your answer is a group, a decision, or a category, then we call it classification. Is this incoming email spam or not? Is the tumor in this X-ray benign or malignant? Let's look at one more example. An autonomous vehicle identifying an object in front of it. Is this object a pedestrian, a traffic light, or another vehicle? Here, we aren't picking a number. We are picking a label. The answer to this question determines which algorithm you will use if you are chasing numbers. You enter through the regression door. If you are chasing decisions and categories, you go with classification. We need to open a very vital parenthesis here. We perceive the world through stories, colors, and words, but computers for them. The world consists only of O South and 1 SIF. Your data consists of digits like age, height, or price. Our job is relatively easy. We call this numerical data, and the computer can perform math on it directly. However, when city names, colors, brands, or genders enter the mix, things change. These are categorical data. You can't just tell a computer this car is red. It doesn't know what the word red means or how it differs from blue. This is the foundation of the magical process you'll hear a lot about later, called encoding. We translate words into numbers so the AI can perform calculations. For example, think of a Netflix algorithm. The genre of the movie you watched might be sci-fi or comedy. The AI codes these as Category 1 and Category 2, because without math, those famous personalized recommendations simply wouldn't exist. Finally, let's discuss the most unshakable rule of this field: garbage in, garbage out. Simply put, if garbage goes in, garbage comes out. Think of AI as a student. If you give them books full of wrong information and torn pages, you can't expect them to give a genius answer during the exam. One of our biggest enemies in the data world is missing values. You have a survey of thousands of people, but half of them didn't write down their age. If you don't manage those gaps correctly, the system starts to fail. Another enemy is noisy data, or outliers. Imagine you are analyzing house prices in a neighborhood. Everyone's house is in the 3 to 5 million range, but someone accidentally adds a 500 million mansion or an erroneous entry into the dataset. This single noisy data point destroys the AI's entire perception of reality for that neighborhood and leads to wrong predictions. Remember, even the best algorithm cannot save dirty data. This is why a true AI specialist spends 80% of their time cleaning, polishing, and verifying data, rather than just building models. Today, we learned what feeds AI, how we read the clues, and how to identify the problems we encounter. We've laid a solid foundation. Now we are ready to clean the mud off the raw diamond. In our next video, we will dive into the heart of how we process this data, the famous data pre-processing stage.